Okay, dear students, in this experiment, see, sonometer, the one the part already now we noted, it has been already uploaded. In that first part of sonometer experiment, we had kept the mass or weight in the hanger constant, 2.5 kg now fixed constant ಇಟ್ಕೊಂಡಿದ್ವಿ. ಆಮೇಲೆ ನಾವು frequency of tuning fork ನಾವು change ಮಾಡ್ಕೊಂಡು ಹೋಗಿದ್ವಿ. ಅಂದ್ರೆ we used different tuning forks and we got different resonating lengths. In this part of the experiment, what we are going to do is, we are going to keep the frequency of the tuning fork constant. Andre ಇಲ್ಲಿ ನಾವು ಒಂದೇ tuning fork use ಮಾಡ್ತೀವಿ. We are going to use only one tuning fork and we are going to change the weight in the hanger, right? So for every trial we are going to increase the weight of the weight by 500 grams or by 0.5 kg. So we are going to increase the weight in this experiment. So by increasing the weight and keeping the frequency constant, we are going to take the resonating length for different weights, right? For 1 kg, one resonating length ಬರ್ತದೆ, 1.5 kg, one more resonating length, 2 kg resonating length, 2.5 kg, 3 resonating length, like this. For every 0.5 kg, we are going to measure the resonating length by using the same tuning fork, and we will note it down, right? Okay, that is what we are going to do. Okay, so this is the chart we are going to follow for this practical sonometer. See, as I have told you earlier also, in sonometer there are two aims. In the first video, when one part of the practical video, we have seen this aim. We have performed this experiment to study the relation between frequency and length of a given wire under constant force. Andre keeping the weight constant. Weight constant itkondu ನಾವು frequency ಮತ್ತು length ನಡುವಿನ relation ನಾವು find ಮಾಡಿದ್ವಿ. Frequency and length were inversely proportional. That we have already got to know, right? So keeping weight constant, we went on changing the frequency of the tuning fork. So ಬೇರೆ ಬೇರೆ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ತಗೊಂಡು ವೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಕೊಂಡು ನಾವು ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ ನೋಡ್ಕೊಂಡ್ವಿ. ಇದು ಫಸ್ಟ್ ಪಾರ್ಟ್ ಏನದಲ್ಲ, ಇದು ಆಲ್ರೆಡಿ ಕಂಪ್ಲೀಟ್ ಆಗೈತ್ರಿ. ಇದ್ರದ್ದು ನಾವು ಆಲ್ರೆಡಿ ಒಂದು ವಿಡಿಯೋ ಒಳಗೆ ಇದನ್ನ ನಾವು ಮುಗಿಸಿದ್ವಿ. ದಟ್ ವಿಡಿಯೋ ಹ್ಯಾಸ್ ಆಲ್ರೆಡಿ ಬಿನ್ ಅಪ್ಲೋಡೆಡ್, ರೈಟ್? Now in this video we are going to perform the second aim. The second aim we are going to perform. So what is the second aim? Second aim is to study the relation between length, resonating length of the given wire, and tension for constant frequency using sonometer. So in the first aim we used to keep weight constant, and now in the second aim we are going to keep frequency constant. ಇಲ್ಲಿ weight constant ಇಟ್ಕೊಂಡು frequency change ಮಾಡ್ಕೊಂತ ಹೋಗಿದ್ವಿ. ಈಗ ನಾವು frequency constant ಇಟ್ಕೊಂಡು ನಾವು weight change ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು. We should go on changing the weight. Clear? That is the thing what we have to do. So we are going to learn the relation. We are going to get the relation between length and tension. Okay. See, there is no need of writing aim, apparatus and procedure in your practical. You have to write rest of the things. Okay. So the second aim is, see what we are going to do, variation of resonating length with the tension. So we are going to see the relation between length and tension. So what is the principle for this second aim? Principle for the second aim is, for given frequency, you know, ಈ ಚಾರ್ಟ್ ನಾವು ಫಸ್ಟ್ ಇದ್ರೊಳಗೆ ನೋಡ್ಕೊಂಡಿದೀವಿ. ಸೊ ಇದು ಫಸ್ಟ್ ಏಮ್ ಇದ್ದದ್ದು, ಫಸ್ಟ್ ಏಮ್ ಪ್ರಿನ್ಸಿಪಲ್, ಫಸ್ಟ್ ಏಮ್ ಫಾರ್ಮುಲಾ, ಕರೆಕ್ಟ್? ಸೊ ಹಿಯರ್ second aim of the principle, second aim of the formula. This is the formula and principle of second aim. Okay. So the principle is, for a given frequency of a vibrating wire, the resonating length depends upon tension in the wire. So ironta frequency ge resonating length depends on tension. So how it depends, that we have to find out. Okay. The formula is T by L square. Tension divided by resonating length square is equal to constant. T is tension. M is mass of the load, S is mass of the hanger, acceleration due to gravity, it should be small g, and L is resonating length, right? So these are the observations what we have to do, right? So now we'll go for the apparatus, we'll calculate and we'll see the apparatus, and we'll perform the experiment now. Okay, before going to apparatus, we'll see the nature of graph as well as observations of this practical. See, the nature of graph is, we are going to plot a graph of tension versus L square. L square is the resonating length square. So tension versus L square. So it will be a straight line, because tension will be directly proportional to L square, or L will be directly proportional to root of tension. Correct? See, mass of the weight hanger, as we have seen already, mass of the weight hanger will be 500 grams, which in kg will be 500 into 10 to the power minus 3 kg. Correct? Okay. Acceleration due to gravity is 9.8 meter per second square. See, load M, and here tension M plus S into G. This load M ಏನದಲ್ಲ, I will take it as M plus S itself. ಅಂದ್ರೆ ಆ hanger the weight na ಇಲ್ಲಿ add ಮಾಡ್ಕೊಂಡೇನ ಬರೀತೇನೆ, right? Okay, so here first what we'll do is, see, for the first trial what we had done, ನಾವೀಗ hanger ಜೊತೆಗೆ ಒಂದು extra weight ನಲ್ಲಿ add ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, slotted weight. 500 grams hanger plus 500 grams slotted weight. So for the first trial we have taken 1 kg. For the first trial we have taken 1 kg. For the second trial, we'll take 1.5 to 2.5, 3 kgs, right? Like this will take the load. Next, tension T is equal to M plus S into G. M plus S under this is already itself is called M plus S. Under hanger the weight and add madidinri, right? So tension antandre nivile yen madbeku antandre you have to multiply it by 9.8. 9.8 then the multiply ಮಾಡಿ nivile ಬರಿಬೇಕು ಅದನ್ನ. Okay. So by multiplying with 9.8, I have taken the value of tension here. So all these are tensions. 1 into 9.8, 9.8, 1.5 into 9.8, 14.7. Like this we have taken. So resonating length, will take it practically there using the instrument. So step by step for every trial, we are going to get the resonating length. Resonating length na note down ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು. And then we'll square and write it, and then T by L square, right? Okay, let us go to the apparatus and we'll find out the values of resonating length. So this is the instrument we are going to use called as sonometer, right? The sonometer has one pulley here. We have one pulley, and there will be two sharp knife edged bridges like this. These are the two sharp knife edged bridges, right? And one end of the wire is fixed, right? See, sonometer has a 1 meter long scale. 1 meter under 100 centimeter. This is 0, and you can check at the another end. It is 100 centimeter, right? So 100 centimeter antandre it is 1 meter long scale. So the sonometer consists of 1 meter long scale. Okay. See, the sonometer has a steel wire here, which will be suspended, which will be hanged from the pulley, and another end of the wire is attached to the weight hanger. See, this is the weight hanger, right? Okay, this is weight hanger, and this weight hanger is of 500 grams, right? This 500 grams is weight hanger is complete, including this hook. This hook weight, all this together it is of 500 grams, right? See, this is of 500 grams, and every slotted weight is of 500 grams. You can check here. So this is also of 500 grams. Okay. So if I add this 500 grams to this hanger, then it will be like this. It is of 1 kg now. It is slotted. The first end namak stand ettala. The hook including hook. This is of 500 grams. This is of 500 grams, and this is of 500 grams. So this is of 1 kg now. So first trial we are going to do it for 1 kg. Correct. So first trial is for 1 kg, and then we'll go on increasing the weight by 0.5 kg for every trial. 0.5 kg to 500 grams for every trial, right? Okay. See, for the first trial, I will keep a distance of 20 centimeter in between the two bridges. 20 centimeter. Okay, after keeping the distance of 20 centimeter in between the bridges, you set the tuning fork into the vibration by hitting it like this. Like this, you hit it and you set it in the vibration. See, you should hold it here. This stem right? And you hit it like this. Don't hit it like this. If you hit it like this, it will set into the vibration. I will just show you how it vibrates and how the sound will come. Right? So like this, you have to vibrate it. So vibrate madi en madsiri, you set it into vibration and you press it on the sonometer. Sonometer mela stem and press madri. It can be kept on the scale or it can be kept on the body of the sonometer also. Okay, I will set it into the vibration and I will keep it here. So now the distance is 20 centimeter. If the paper vibrates, then it is okay. If it vibrates slowly, you increase the distance by 1 centimeter. And again you set it into vibration, you keep it here, you check the vibration. If it increases, if the vibration increases, increase the distance again. And at some distance, you will find the maximum vibration and the paper will fall down. So ಎಲ್ಲಿವರೆಗೂ paper vibrate ಆಗಿ ಕೆಳಗಡೆ ಬೀಳಂಗಿಲ್ಲ ಅಲ್ಲಿವರೆಗೂ you go on increasing the distance by 1 centimeter, right? ಅಥವಾ 0.5 centimeter increase ಮಾಡಿದ್ರೆ ನಿಮಗೆ accuracy ಸಿಗ್ತದೆ, right? So this is what we are going to do. So first trial 1 kg mass ನಾವು ಇಟ್ಕೊಂಡಿದ್ದೀವಿ, weight ನಾವು ಹಾಕಿದ್ದೀವಿ, and 20 centimeter distance ಇಟ್ಕೊಂಡು we are going increasing the length, right? And we will get the resonating length. Okay, so we will keep the tuning fork a constant here. Same tuning fork we are going to use for all the trials. What we are going to change? We are going to change the weight. So I will add 500 grams more weight for that. 500 grams more weight, 1.5 kg net gotini, and again I will I will continue the same process. 1 centimeter ನೀವು ಮತ್ತೆ increase ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ, and then ಅದರ ಮೊದಲು ಎಷ್ಟು ನಿಮಗೆ ಸೆಂಟಿಮೀಟರ್ ಬಂದಿರ್ತದಲ್ಲ ಅದರ ಮುಂದಗಡೆ ಮತ್ತೆ increase ಮಾಡ್ರಿ. First trial ನಿಮಗೆ resonating length ಎಷ್ಟು ಬಂದಿತ್ತಲ್ಲ, you go on increasing from there only by 1 centimeter for every trial you take, right? So like that we have to increase the weight by 0.5 kg for every trial, and we have to take the resonating length, right? We'll have a closer look of that now. These are the sharp knife edged bridges. See, first how to take the reading I will tell you. So this is 65. So first resonating first wave bridge ಏನದಲ್ರಿ sharp bridge 65 ಅದ. So straight line exactly 65 coincide ಆಗೈತ್ರಿ. right? So it is at 65. Second one sharp edge nodri, it is at 45, right? So 65, 45 means it is at, so the distance between them is 20 centimeter. For the first trial, I have taken the mass as 1 kg. 1 kg na tagondidini, distance na 20 centimeter itagondidini. So you should hit the tuning fork and you should set it into vibration and place it on the sonometer, check the vibration and go on increasing the distance by 1 centimeter, right? Okay, we'll take the first trial now. Okay, see. Okay, see, we'll set it into vibration and we'll press it on the sonometer. See, now the distance between the two bridges is 20 centimeter. This is at 65, this is at 45. So 20 centimeter is the distance. Okay, I will set it into vibration and I will press it. You just check the vibration of the paper writer. It is vibrating very slowly. Okay, increase the distance by 1 centimeter again. Okay, so we'll increase the distance by 1 centimeter and then we'll check again. So set the tuning fork into vibration and then hold it. Yes. So this is how the paper writer will fall after the resonance has occurred. Okay, now we'll see, we'll take the reading, that is resonating length. Okay, just check what are the positions of this. See, this is at 65, one bridge at 65. I have kept this constant and I was moving this by 1 centimeter, right? So you can check where is this now. See, it is, okay, see, it is at 42, correct? So this is at 42, this is at 65. So 65 minus 42, this will give you 23 centimeter, right? Okay, see, for the first trial, the resonating length is 23 centimeter and the mass we have kept is, weight we have kept is 1 kg. For the second trial, we have to add 500 grams more. It means for 1.5 kg. See, for second trial, what you do after putting 1.5 kg, you start the trial from here only, from the same length. Go on increasing 1 centimeter for every trial and then you check the vibration, right? So you will get the resonating length. So I will continue this. I will take all the trials, all the readings, resonating lengths, and then I will directly come for the calculation now. Okay. Okay. So after taking all the trials, I have noted down the resonating lengths here, as well as I have calculated L square and T by L square. Right? So for the first trial, resonating length was 23 centimeter. Adana meter work 23 into 10 to the power minus 2. Similarly, 27 centimeter, 30 centimeter, 33 centimeter, 37 centimeter. Right? See, as we go on increasing the tension ನಮಗೆ 9.8 ಇಂದ 29.4 ತನಕ increase ಆಗಿದ್ರೆ. So the tension has gone increasing. Clear? What happens to the resonating length? Resonating length ಏನಾಗಿದ್ರೆ 23, 27, 30, 33, 37. So resonating length has also increased. Yes, so it means that tension and length both are increasing. Eradu namge increase agatavri, right? And what about L square? L square is also increasing. So tension, see, L is increasing, that's why L square will also be increasing. So it indicates that tension is directly proportional to L square, right? That is the principle of this experiment. Okay, so we got to know about the relation between T and L square. T and L square, T is directly proportional to L square. Now we'll go for the graph and we'll plot a graph of T versus L square, right? Okay. Okay, now let us plot the graph of tension versus L square. See, this is x-axis and this is y-axis. So on x-axis, we are going to take tension. So on x-axis, we are going to take tension, which will be Newton, right? And on y-axis, we are going to take L square, resonating length square, which will be in meter square on y-axis. Clear? Okay, see how to plot the values now. ಈಗ values ನೋಡ್ರಿ ಯಾವ ತರ ಪ್ಲಾಟ್ ಮಾಡಬೇಕಿಲ್ಲ. ಟೆನ್ಷನ್ ನೋಡ್ರಿ ಯಾವ ತರ ಅದ, ಇಟ್ ಇಸ್ 9.8, 14.7, 19.6. ಅಂದ್ರೆ ವೇಟ್ ನಾವು ಯಾವ ತರ ಯೂನಿಫಾರ್ಮ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗಿದ್ದೀವಿ. In the same way, uniformly the tension has increased. So nothing to worry here. You can directly put the values. 5 values ಅದ ನಮಗೆ. So here 1, 2 for every 2 centimeter. One box ಅಂದ್ರೆ 1 centimeter ಇರ್ತದ್ರಿ ಇಲ್ಲಿ. One box means it indicates 1 centimeter. For 2 boxes, I am putting 1 value. So 1, 2, 3, 4, 5, right? So the first value is, see the values of T. It is 9.8. First one is 9.8. Second one is 14.7. And then 19.6, 24.5, and 29.4. Correct? So like this, we will get the tensions. Next, we have to plot L square values here. L square values nodri namge yav tara adava. How are the L square values? It is 0.0529, 0.1369. Illi vargu namge L square values adavri. So we'll start 5 trials we have to take. So we will start from 0.50 then, right? 0.50. For every 2 divisions, I will take 1, 2, 3, 4, 5, 6, 7, like this. So if this is 0.05, 0.06, 0.07, 0.08, 0.09, 0.1, 0.11, 0.12, like this we'll take it, right? Okay, we'll take the values like this. So this is 0.5, 0.7, 0.2 will go on increasing. Sorry, this is 0.05, okay, 0.05, 0.07, 0.07, 0.09, and this is 0.11. So 0.05, 0.07, 0.09, 0.11, right? And 0.13. This is 0.13. This is 0.15. Like this, we are taking the values, right? Okay, let us write the scales first. See, scale. We'll write the scale now. So for x-axis, the scale will be, see, for every 2 centimeter, we have taken 1 value. Prati 2 box ಗೆ ನಾವು 1 value ತಗೊಂಡಿದ್ದೀವಿ. So here I will write 2 centimeter equal to. See, 14.7 minus 9.8. How much we will get? 14.7 minus 9.8. It is 4.9. Right? The difference between them is 4.9. Similarly, 19.6 minus 14.7, 4.9. So the difference between each value is 4.9. That's why I have to write it as 4.9 Newton. Right? Newton yakre, because we have taken tension on x-axis. That's why here it has to be Newton. Okay, now the scale of y-axis we will write. The scale of y-axis. So in y-axis also, what we have done is, we have taken the values for every 2 centimeter. Prati 2 centimeter na onond value hakondivi. So how much is the difference? 0.07 minus 0.05, 0.02. 0.09 minus 0.07, 0.02. Right? So this is 0.02 meter square. 0.02 meter square. This is the scale. Okay, now plot the graph. See, values nodkonta hogri, graph plot madri. So just check the values and then plot the graph, how it will be. See, for the first trial, it is tension is 9.8, and how much is L square? L square is 0.529. So 9.8 is 0.529 means somewhere here we will get it. 14.7, 0.0729. 14.7, 0.0729. Somewhere here we will get it. 0.07 is here, so 0.0729. Next, 19.6. 0.0900, 19.6, 0.0900, correct? Next, for 24.5, 0.108, 24.5, 0.108, 0.108 means it will be just below 0.11. So somewhere here it has to be. Next, 29.5, 0.13. So 29.5, 0.13. Here I will get the point. So after plotting all these values, from the origin you have to start the straight line and join the points. Okay, keeping the scale from the origin, I will join all these points now. Right? So you have got a straight line. Clear? So what does this graph indicates? It indicates that tension is directly proportional to L square. Right? So this is the result. Okay, now let us know the result of this experiment. See, the result of this experiment is like this. See, the value of t square, okay, just leave that. Second point order. The graph between t and L square is a straight line. Yes, we have got a straight line, correct? So third point is, this concludes that for a given frequency of vibrating wire, under frequency nam constant itte, fixed frequency itte, the resonating length is directly proportional to the square root of tension. Resonating length is directly proportional to square root of tension. Namage en bandade? T is directly proportional to L square. So square root hakonಡ್ರೆ ನಮಗೆ ಇದು ಬರ್ತದೆ. So that is the result. Right? So dear students, this is all about the sonometer experiment, and all other experiments are also uploaded. Please go through the playlist. If you like the content of this channel, please don't forget to subscribe the channel and share the channel with your friends. Right? So ದಯಮಾಡಿ share ಮಾಡ್ರಿ, video share ಮಾಡ್ರಿ, channel share ಮಾಡ್ರಿ, and please keep watching and supporting the channel. Thank you so much. If you need anything else, please put a comment. We'll surely make a video on that. Thank you.